Hello everyone, and thanks for joining us for today's webinar on data quality, building data pipelines with bad data in mind. Our presenter today is Kevin Scott, our solutions architect here at Clover DX, and he'll be discussing bad data in your systems and ways to design processes to deal with it. Just a couple of housekeeping notes. Kevin will be answering questions at the end, so if you do have any, please just use the Q&A box, submit them. Also, we'll be sending out both the recording and the slides after the webinar. So with that, I'll hand over to Kevin.
Great. Thanks, Tessa. Hello, everyone. Thanks for joining. Of course, as with all our webinars, we're here today to talk about data and data pipelines. Today, specifically, data quality. Getting data from wherever it is to wherever you need it to be without propagating or introducing quality-related issues. So let's level set first with a definition. Data quality deals with assessing your subject data to make sure it's fit for your intended purpose. A lot of dimensions, accuracy, completeness, consistency. When poor data creeps into your systems, it can affect credibility. We need our audience to be thinking about what our data means, not questioning its validity. And if poor data does get in, it can be expensive to repair, both the reputation of your data and in some cases, actual damage to the repository. Gartner has published numbers on the costs of poor data quality. And in fact, they've got a magic quadrant for software vendors who specialize specifically in data quality. So first, where does bad data come from? Well, the opportunity to collect and memorialize bad data is everywhere. Point of origin errors are probably the easiest to understand. Most data begins with some sort of human interaction, filling out a form or keying in information. Bad data can also come from or be introduced by software. A new release of software may write data in the wrong spot. And systems just naturally evolve. Features get added or removed, but maybe the associated data structures don't move in tandem and can become collection points for bad data. So let's look at some examples, might be helpful just to show how easily poor data can get into our systems. We'll start with dates and date formats, probably the most classic source of error and certainly not a new one. We've been dealing with date format issues for hundreds of years, sometimes even changing formats in mid-sentence. And date format issues continually find new creative ways to permeate our systems. Maybe we find a web page that's got some data that we'd like to capture. So we copy, paste it into Excel. Quick visual inspection looks okay, but if we take a closer look at what happened with Excel on the date format, we realize that we did a transposition, mainly because I'm in the US and the website was published in the UK. So where I thought I was getting data for the first 12 days of December, I actually captured the first data for the first day of each month of the year, right? Dates are particularly, date errors anyway, are particularly resurgent lately with string-based APIs. Most API endpoints today return everything as strings, JSON, for example, and you might make those API calls, get your result set back, put it into an S3 data lake, and then maybe downstream a little ways, move it from your S3 data lake into a document database, all treating that information as strings until at some point, someone needs to actually transform, analyze, or otherwise use that data. They need to make sure that they've kept track of what the original format was so that they can ingest it correctly and also link back to source records. User interfaces are another common source of poor data quality issues, particularly evolving user interfaces. We might start with something on the left as a call log recorder, where one of the fields is free text. But over time, as that application evolves, we switch from free text to something that looks maybe more like on the right, where we've got a pull down for the type of call, so we can more discreetly capture the call type to help put it into our warehouse in some way that might be easier to analyze, right? So the user interface evolves, but maybe the data structure behind remains constant. The data structure that holds that call type was text and remains text. So now we've got a table with entries from the original user interface and entries from the current interface. That doesn't get broadcast downstream. Consumers of that data might not be aware of the variation, might not be designing their use of that data with this variation in mind. Programmers, of course, can be a source of data errors. A simple transposition in an insert statement can end up putting the wrong data in the wrong column, and something like that could go unnoticed for unusually long periods of time. And finally, case sensitivity, right? A situation where maybe your data pipeline is dealing with image processing. So you ingest an image with a lowercase extension, but some other process along the way, maybe on a Windows machine, inadvertently upcases the extension, and in doing so created a duplicate copy of the file. Other downstream stages, maybe a relational database, which was case insensitive, doesn't see two files, only sees the one. So duplicate image inserts end up failing. Remnant files end up left on disk because some of our stages in our pipeline see two files here. Some of our stages may only see one. And you end up with orphan images. System gets crufty. So there are lots of ways poor data can arise and get into our systems. So let's talk then about ways that we can respond and handle those situations. And the first thing to notice when we do this is that most data quality issues arise when you put your data in motion. There are, of course, times where static data can end up getting poor data quality, but in the most part, it's the movement of data, whether it's an integration or you're ingesting new data into your system or reshaping your data for use in some warehouse. It's the movement where the data is at higher risk. And that movement typically involves a data pipeline with multiple stages, each of those stages capable of introducing or allowing poor data to creep in. It can happen at any stage. Further, it can snowball, right? So something that's small early in the data pipeline can actually grow into quite a large problem. Maybe think of a situation earlier where a GUI changes and I have new items in a pull-down menu. But when I go to use that field as a lookup, there's nothing returned, so that's null. And then that looked up field might have been a key for a join, so now I'm not getting data joined in to make the set richer. And so you eventually get to the point where you've got maybe technically correct rows, but not enough of them, or they're sparse, and you end up giving your end consumer improper or invalid results. Right, so data in motion is data at risk, and there are things that we can do in our data pipelines to mitigate this risk. So what I'd like to do now really is go through 3 actions that you can take when you design your data pipelines to keep poor data quality in mind. Right, we'll start with what I'm calling validation and profiling. The most obvious response to bad data, to prepare for bad data, is to add stages to your data pipeline that explicitly deal with data quality. They can go anywhere in the pipe, but minimally, think about adding bookends at the front and the back of your data pipe to scrutinize your data on the way in and on the way out. We often think of these kinds of explicit data quality checks in two different categories: validation and profiling. Validation is the most common type of data quality check, where you apply business rules to each record at a particular stage. Does an ID field have the right number of characters in the correct expected pattern? Is the begin timestamp and the end timestamp, is the begin timestamp less than the end timestamp, and are both of them in this quarter? There are 3 phone number fields. Do I have at least one that has a valid phone number? These are all business rules that we can apply record by record to some data set. It might look like this: individual records run through a validation stage, and we apply multiple rules. The records that pass all those rules get advanced to the next stage in the pipe. Records that don't get pulled out and placed someplace else for assessment. We can also take the opportunity, as we're pulling those records out, to do a quick report, to aggregate and to try to characterize the number and types of bad records, just to help speed the resolution. Right? So here's just to get closer to some real tooling. This is a validator rules editor, something that might be used to edit or configure a validation stage in your pipeline. Right? You can see over here on the left, in the upper left-hand corner, the data set that's coming into this particular stage of our pipeline. It's got these fields. Below that, a set of rule templates that we have to choose from. And then in the center, the rules that we've defined for this data set, grouped logically, right? So for the name rules, make sure that I have at least a first or a last, ideally both, but at least one or the other last name, and that the names that I have are less than some expected length, right? If they don't pass that, if the file doesn't have a record doesn't have a first or last name, then it's going to get rejected. Other fields have their own rules. The email field has a rule that says empty emails are allowed, but if there is a value, it better be syntactically correct, or we're going to pull that record from the data flow, right? So a traditional validator rules editor for the validation stage of a pipeline. Profiling, the sister, I guess, of validation, is a little less obvious data quality check. Unlike validation, where we're looking at each record one by one and applying business rules, profiling is generic and independent of any business rule. It takes an entire data set and creates a statistical profile that can be used to detect questionable data and prevent it from entering the system or moving through your pipeline. Right, so we can take a look at some pictures of that. Here's a typical set of statistics that a profiler might produce. I've got, I see here that the data set I'm profiling has 18,000 records. These are the fields in those records. I've got a column over here in my profile that assesses, how dense everything is populated. I'm in good shape here. I have nearly 100% population of each of the fields in my records, with there may be one field accepted. If I look closer at the birth date field, that's coming in as a string, but I can see that the minimum and maximum length is 10, and that 100% of the values in this column of this data set all have this pattern: 4 9s, 2 9s, 2 9s. So I know that this date field is, even though it's a string at this point, is in good syntactic shape. Another field, only 1 character long, and I can actually see that this particular thing has the entire data set only has 2 distinct values. Some profilers even have a visual inspector where you can actually inspect the data. Here I see that of the 2 values, Those are what the two values are, and this is how they're distributed. So all of these statistics taken together create a profile for some data set or some data table. Periodically running this profile and comparing it with previous results can give us some early warning that a data set or a data table or a warehouse might be starting to decay, or that data quality issues might be starting to creep in that had been previously undetected.
Hi, Kevin. We seem to have lost your volume.
Oh, yep. Tessa, can you hear me?
Yes, we've got you back now. Thank you.
Okay, sorry about that. Just moving on then to the second good response to bad data, which is looking at data quality in each pipeline step. Right, so we know that, or we should anticipate anyway, that poor data quality can emerge from any stage in the data pipeline. So we want to try to capture bad data as close to the cause as we can to allow efficient resolution. If we don't make that attempt to capture those issues as soon as they arise, but instead allow them to propagate downstream into multiple stages, further stages of our pipeline, it can become much more time consuming to track back and figure out where exactly the data quality issue initially arose. So capturing at each step is a good practice, akin, I suppose, to the software world of unit testing application software. And I'm sure if there are programmers in the audience today, they are all very adamant about writing unit tests for each method that they create. Thus, a similar parallel for our data pipelines. Third response that I have for you today about managing is to actually consider managing responses to your data errors as opposed to just capturing them. All right, we can consider a data error manager, which can act as a central hub, collecting rejected data from the main processing line and providing an effective way to correct and reprocess bad data or data quality related issues. So data error management can take a number of forms. It can be a combination of people and process and technology. A data error manager can often use the same data platform as the main job, right? The main job has stages of moving data from source to target. The data error management platform or process can have stages sort of moving data. It's a pipeline that's moving data in the opposite direction from each of the individual stages back through some corrective transformation process and preparing for reprocessing, right? So the technology that you use for designing your mainline data flow can also be used for designing the sort of backflow pipeline. If there are people involved in the data error manager that you create for your pipelines, it can be tempting to use IT staff. IT staff is maybe typically the first person to detect or become aware that there are errors or data quality issues in the data. But why they might be the first to detect, the IT team is probably not the best choice for actually making the corrections, right? They may not have the right business context to know how to correct a particular set of data issues, or they may not have the authority to make those changes, even if they do know what the values are. But more deeply than that, having IT in charge of making these corrections can be a missed opportunity to correct the issue at its source and prevent IT from having to correct it again, next week. So best to involve business users or domain experts in the data error manager process as someone who knows how and when to correct particular data quality issues. The last point about data error management is that each of these stages that's reporting into the data error manager should use a standard format for how it reports that error. Now, it may be that each of these stages has a different data format. You may be ingesting flat files, transforming them into JSON objects before loading them into relational tables. There could be native formats, different native formats for your data as it moves through the pipeline. Well, we don't want the data error manager to have to deal with those formats. We want the data error manager to focus on the actual data quality issue. So if we standardize and have each of these steps report to the data error manager in a way that a human can check if it's involved, in the way that we can do bulk fixes, or in a way that we can report back to someone at the source end who knows how, and give them an actionable piece of intelligence to correct, as opposed to, say, a database dump. Right, so poor data quality is going to seep into our systems most frequently when our data is in motion. And so we've talked about ways to design pipelines to capture that bad data, and ideally to automate the remediation. The process has one very interesting side effect that can be of important business value, and that's data about your bad data, right? So capturing and collecting data about your bad data can have important business value, right? It can allow you to identify flawed processes or training issues close to the source. Maybe you've got one part of your business that is using a misconfigured piece of infrastructure. Collecting bad data, collecting the data about your bad data might lead you to discover that in a more timely fashion. You can also uncover and reconcile differences in the way your data is being interpreted, right? We've been talking about collecting data, but once we get data about bad data, it starts to point perhaps to differences of interpretation, where one team might be interpreting a data set differently than another team. And so analyzing the data that comes out about your bad data can uncover that, as well as allowing you to identify and standardize business definitions, right? If you've got different teams that might be thinking of statuses for a particular type of entity, those differences in those definitions might surface as quote unquote poor data quality. So designing a data pipeline to handle bad data not only improves the immediate data quality in your systems, but it can also provide unique and valuable insight into your underlying business processes, surfacing issues that you might not have otherwise been aware of. So we have some great resources on our website where you can learn more about data quality and data quality strategies, and read some of our real-world implementation stories. I encourage you to visit there if you're interested. But with that, back to you, Tessa.
Thanks, Kevin. I hope everyone found that interesting. We have got some questions that have come in, so I'm going to throw a couple over to you. We've got someone that's asked, it's nice, but it sounds like a lot of money.
Right, that's a common reaction, right? Testing in the software world is also, sort of a parallel world if you come from the software side of things. But you really need to put risk management in context with this price, right? What is poor data quality going to cost you? If you're a large organization, some of our customers are, where poor data into a system can result in lost revenue or fail to do correct billing. And there's a quite easy way to assign a monetary value to the risk of not doing that. So it becomes a value judgment, assessing the cost of having that, the cost of the risk of having that bad data versus the cost of doing the implementation.
Great, thank you, Kevin. We've got another one. How do I help my people stop inputting bad data?
Right. Well, as I think, as I sort of pointed out earlier in the presentation, that is probably one of the most common ways for poor data quality to enter the system, is if end users or staff at some point in your organization miskey or misenter. And we find that actually using something like a data error manager that creates a report that you can carry back adds some additional weight to any training exercise that you might provide to your team. If you can say, look, we're going to train you how to use this interface so that you use it correctly, and here's why, right? Because some of the data that you get miskeyed ended up getting into the system this far and actually affected our ability to execute on some project, right? So being able to, I think, show them concrete results of poor error data getting in can be pretty influential in training a team.
Yes, so we have another one. Can machine learning be applied to this problem?
Machine learning. Sure. I mean, machine learning seems to be a hot topic these days, and it's always good to automate as much as possible any stage of our data processing world. I could think of machine learning maybe involved in discrete stages, as I mentioned earlier. Maybe at the beginning when you make an assessment of an incoming data set, or when you're profiling. Profiling, I think, if you really loosen the definition of machine learning, could, almost fit into that category, where you just blindly do statistical assessments of data completely independent of business context and look for patterns, right? So in some senses, you start to see machine learning type theory applied in data quality. But there is fundamental risk, I think, in introducing artificial intelligence into these things, and that there's, some chance of ambiguity, right? You don't know what decisions it's making. So I'm not sure we're to the point where we can rely on machine learning, but it certainly seems like it can be an important and interesting stage in a data pipeline.
Thanks, Kevin. We've got another one. So someone has said, my question is about how to handle this much data for correction. And can we apply feature selection techniques on the data by which we can ignore the correction on some part of data?
Right. Again, that vocabulary reminds me of data science and maybe some machine learning. But with a good data platform, selecting which fields you want to have included in a profile or in a validation stage seems to be something that you could make configurable, so that you could rerun and alter or very easily change which columns or maybe which features of a particular data set. So not a data scientist by training, but with the technology we have in these data pipeline tools, I would think that being able to parameterize how these data quality stages operate would help in that kind of to do that kind of thing.
Thanks, Kevin. We've got another one come in. Any recommendations for documentation of these processes in a way that's accessible to less or non-technical staff or data users?
Mm-hmm. Well, again, I would point back to technology, right? We like to automate as much as possible some of these things. A good data pipelining tool. I mean, we're talking about data pipelines today, right? And we are actually a vendor of a data pipeline, but our data pipelines have self-documentation, right? So that they actually produce rich HTML documentation about what happens at each stage, including the rules that are applied and what you can, that essentially makes a good sort of controlling document about how the system is designed. And then of course, the artifacts that are produced by your data quality stages can also act as documentation, right? If you start to want to create reports of the types of poor data that are coming through, you know, when they come through, what types they come through, and in what volumes, and maybe tie them back to business activity. So I'm not sure if I answered that question, but we do have some documentation, you know, some self-documenting features built into our ETL platform, our data pipelining platform.
Okay, thanks. We're just about out of time now, so thank you to everyone for your questions. If you do have any follow-up questions you'd like to ask, you could drop us a line at the email on screen, hello@cloverdx.com, and we'll make sure Kevin gets those. So yeah, thanks Kevin for a really interesting webinar, and thanks for everyone for attending. Recording and slides will be in your inbox soon. So we hope to see you at our next webinar, which will be in 2 weeks' time on data services. Thank you.
Thank you.